Today, we're diving into a topic that's both complex and crucial: AI in medicine. Specifically, we'll be discussing black box models and their implications. We all know deep learning is a big deal now, right? It's used across numerous fields and has started to make significant inroads in healthcare, which is incredibly exciting. But as with any powerful technology, there are some valid concerns we need to address. So, let's break this down. Deep learning is a type of machine learning involving complex models, known as neural networks. These networks are loosely inspired by the human brain, made up of interconnected nodes that process data in intricate ways. The reason deep learning has become so widespread is due to the availability of massive datasets and advancements in computational power. We had the foundational knowledge before, but now we have the oven to bake the cake, so to speak. This leap has propelled deep learning applications, including in the medical field, where it shows great promise for early diagnosis and new treatment strategies. Now, this is where black box models come into the picture. These are deep learning models that perform exceptionally well but are difficult, or nearly impossible, to interpret. Despite their impressive capabilities, we can't easily trace how they arrive at their predictions. Imagine trying to follow a single raindrop in the middle of a hurricane. That's what understanding these models can feel like. So, while they may outshine traditional models and even human experts in certain scenarios, this opaqueness poses real challenges, particularly in medicine. Think about it. An AI that accurately diagnoses a rare disease based on a patient's symptoms and history could be life-changing. But what happens when a patient asks the doctor how the AI reached that diagnosis, and the best response is, "The computer said so"? That's unsettling, right? For a field as critical as healthcare, interpretability is essential, not just for the sake of doctors making informed decisions, but also for building trust with patients and meeting regulatory standards. So, are we stuck between a rock and a hard place with accuracy versus interpretability? Not necessarily. Researchers are working tirelessly to bridge this gap. One promising method is called LIME, Local Interpretable Model Agnostic Explanations. Instead of dissecting the entire model, LIME looks at which features in the input data most influence specific predictions. It's like analyzing the key ingredients in a recipe without having to decode the whole thing. This approach doesn't solve everything, but it's a step toward better understanding these complex systems. As we move forward, there's hope that we can achieve a balance between high accuracy and clear interpretability. This isn't a binary choice. It's more of a continuum. With ongoing research and practical experience, the transparency of these models can improve over time. This would enable us to harness their potential fully while addressing the concerns that come with their current limitations. So, what's the main takeaway here? Be cautiously optimistic. Deep learning in medicine holds tremendous potential, but we must stay mindful of the challenges it presents. We should continue advocating for research into interpretability and transparency. The more we understand these black box models, the better equipped we'll be to use them effectively and responsibly. And that's something worth striving for. Thanks for watching. Don't forget to like and subscribe to our channel.
See you next time.